So first, hi, my name is Clément Christomanos. I'm a co-founder and CEO of Uavia. So Uavia is a startup company we funded in 2015 with two co-founders, Pierre and Luc, two CTOs. So obviously I'm not as technical as the other profiles that was before. So two co-founders which I've met in engineering school, and Uavia has been founded with that precise fact in mind that artificial intelligence will, in fact, allow drones to become more and more popular among enterprise and large corporations. In fact, I'm not even here to ask whether or not it will be. The question is really how artificial intelligence will help drones to come into large corporations. This precise assumption, it just struck us in 2015, and I'll start by telling you the journey, because the journey is more important than the destination, and hopefully I'll have put a little perspective on the development of drones, their history, and how artificial intelligence will be the next drone revolution, if I may. So I'm gonna start where it all started. It all started in engineering school. So I've always been passionate about two things. The first thing is computer science, and the second thing is everything that flies. I've always wanted to be a pilot, and I ended up in engineering school. Well, happens to a lot of people. So I've joined Telecom Sud Paris to become an engineer. And for most of my first year, in fact, I spent my first year doing just electronics, with still both these interests in mind, aviation, stuff that fly, and computer science. And that's during my first year that I've met this guy. So this guy is Pierre. He's a co-founder at Uavia and the CTO. And he was always playing with drones and hacking them, you know. But I knew nothing about drones. I just thought it was the same as a radio control plane. And what I've seen is just that drones were not really reliable at the time. So Pierre just kept like crashing his drone. And in the meantime, I just asked myself, well, where do drones come from? So that drone you've seen on the picture, this one, and you've seen Pierre with. In fact, it's a drone that's been made by Parrot, a very famous French company. So you all know Henry Seydoux, and Henry Seydoux, in the beginning, he wanted to launch an RC-controlled car, a radio-controlled car, he knew, in fact, what I've experienced, that lots of young boys and young girls dream of flying, and one does really not easily become a pilot, and it's very expensive to actually get flying hours. So he told himself, what if the next toy, the next car would actually fly? And he basically invented, with his company, something that will allow everyone to fly by proxy, which was a very first step and very, very important step. So he's got the money, he's got a company filled with very talented engineers, and he invented this toy. So it was really the beginning of a new era, because everyone will hear about drones and imagine anything with drones. Pretty crazy stuff too. So let's just start with what's really a drone, because lots of people tell me, yeah, drones are just aircraft without a pilot. But this is precisely wrong. There is still a pilot. It's just that the pilot is on the ground. It's not on board the drone. So he's just from the ground and controlling the UAV, unmanned aerial vehicle, remotely. And of course, drones have not always been toys. The very first drone was actually a military one, and surprisingly, it's not the one you see on the picture. It dates back from World War I, so 1918. The very first drone was called the Kettering bug, and there was a scale on 0 to 10 to grade its intelligence. If we are about to talk about intelligence, the grade will be somewhere like -12, because all it could do was just basically crash on something, keep in the direction, you know, just crash on the ground 120 kilometers later. So it was just like a flying torpedo and nothing more. Fast forward a few years, humans like war. So you all know the V2 too. It was very deadly, a very deadly missile. And it's a first technological step that's very important to drones, because basically German engineers, Nazi engineers in fact, invented flight control. That's the very first craft with an autopilot on board. It was not controlled by the pilot on the ground, but it could do a lot more than actually just keep its direction. So During the war, there were more and more drones and more missiles like this that could actually fly a bit smarter and have real flight control systems on board. And you all know how this ended. V2 actually gave birth to the first rockets and the space race. So soon after the war, German engineers were actually kept by Russia and by the United States, and it was the beginning of the space race. And it was also the real beginning of modern electronics, because when you think about it, integrated circuits already existed by the time, but they cost something like $1,000 each. And the NASA ordered so large quantities of integrated circuits that the prices dropped to like $20 each. And it was the beginning of modern electronics that we actually see in every military drone now. Now, what's really interesting is that it's the same technology, basically, that flew rockets in the Apollo era and that fly military drones now. So it's very expensive technology, aeronautics graded technology, and it costs pretty much $100,000 to get an accelerometer to get on board these drones. The real revolution came from airbags. So a lot of people in the 80s actually used cars, and there were lots of car accidents, and car manufacturers told themselves, what if we could invent something to save people's life? So one of the technical challenges to actually develop airbags was how to detect the shock and when to trigger the airbag precisely. This could be done by using an accelerometer, but the problem is that you can't really fit a $100,000 accelerometer inside everyone's car. So a few geniuses at Analog Devices actually thought of a way to do it. It was called MEMS, Micro-Electrical Mechanical Systems. And these systems were expensive back then, but not so much expensive after the smartphone era, because every smartphone has an accelerometer inside. And all this combination of hardware evolution just gave birth to drones, because everything was ready. All Henry Seydoux has to do was, in fact, assemble pieces of technologies coming from there and there. And basically, the smartphone era enabled this. So it's just like a toy, and pretty much not an intelligent toy. So all it could do, and all it does, is to actually answer what the pilot on the ground is telling him to do. So there's not so much intelligence on board. This kind of drones are automats, not really robots. What I mean is that their pilot on the ground gives them instruction, and they can fly automatically, but not autonomously. They cannot take their own decisions. So that's the first fact that actually struck us when we started the company, is that for all these years, the hardware evolved a lot, but the software, it did not know really a huge progress, because in the end, there was still pilot taking all the important decisions and the decisions that matters. So you all know the rest of the story. The toy market quickly stabilized, and it's now dominated by Chinese companies like DJI, Daigen. And since 2014, drones were actually used as a tool. Lots of companies actually saw great potential in drones in a lot of use cases, like modelizing sites in 3D using photogrammetry techniques. It means taking pictures and assembling a 3D model from the pictures. So this enables site analysis and making volumetric measurements on a site to save money in comparison with classical measurement means. It's often used for cartography in the building industry, in the environment, etc. It's used a lot by insurers, for instance, after a disaster to help with claims management. Obviously, what it gives is an easy access to the third dimension, so 3D. But what I really mean with 3D is the dull, the dirty, and the dangerous. That's the playing territory of drones. For instance, it's way cheaper to actually use a drone than to set up a crane. It's way less dangerous to use a drone than to hire climbers. And well, large corporations, they always told me, like, well, it's a lot cheaper than a helicopter. And yeah, they were right. But it's not the most important benefit, in fact. And you'll see it later. So it was used, for instance, on inspection on oil refineries, in agriculture, to quickly locate exactly where plants needed water or treatment and apply it locally instead of applying to the whole field. But well, all the effervescence about this use case, what it ended up being is just an era of service. Lots of people and individuals saw an opportunity there, and they told themselves, well, if I bought a drone and create my own company and create a drone service company. So for the last few years, about 5,000 people in France tell that, and it's the same pretty much everywhere in the world. And large corporations began to use these service companies for the tasks I've been showing you. So a few times a year, sometimes once a month, tops, nothing more. And in that time, the technology began to become more mature. So some large corporations actually told themselves, what if instead of taking a cab every day, I just bought my own car? And some actually did, because there was a huge interest to do this. Because when you're on an industrial site, there's a need so large that you can use drones not once a year or once a month. You can use it every day. You have lots of things to do on an industrial site. You could do your perimeter security with drones. You could do problem detection, routine maintenance inspections, etc. The problem is that when you're a large corporation, a drone looks just like this, just like the space shuttle, because it's incredibly complicated. It's very highly regulated. It's quite risky to operate over a large industrial site. So what do you end up doing when you're a large corporation? You buy your own drone, and after that, you end up hiring your own driver, and it costs you a lot more money, even. And that's precisely the point we're trying to solve at Uavia. So what we've done with that is really simple. We just did what's obvious to everyone, putting back a pilot on the plane. But that pilot is an artificial intelligence, an AI. And the same way you talk to your cab driver, just telling him your direction and your destination, and not telling him every input on the steering wheel he needs to do, we've done pretty much the same. So we give our customers give very high-level orders to drones, and the drones will directly interpret them on board the drone directly. And we are using the cloud to connect these customers to their drones. So if I take an example, like scanning an industrial site, and let's count the number of cars on this site. So that very simple order is actually given to a drone and transmitted to the cloud, and that's pretty much anything that's transmitted to the cloud. The onboard systems are going to analyze tons of data to know whether they can do it or not, etc. What's the battery remaining? Are my motors in good health, etc. And our system will just accept or deny the data and make what really matters imported to the user. For instance, you've got no interest in knowing that the battery voltage is just at 32 volts. You just want to know how much time you got left for your mission and how much time you got left for your operation. So our job is to actually complex, very technical data and complex data into user actionable data. Our drones will, for instance, be able to know the shortest path to actually scan the site and make that mission a success. So the first use case is to just make drones simpler and easier, and this happens directly on board the drones, which is very important. One example of this is pathfinding. I mentioned it. The drones know how to find their own way to achieve a mission. Finding a way through a very complex environment filled with obstacles. That's a very well-known problem in video games, for instance. Something aeronautics engineers did not do a lot. Well, our generation did, and the first thing we did was implementing these video games pathfinding techniques directly on board drones. And you're going to tell me there's no AI in that because the output is deterministic. And you will be true. If you get like a source and a destination and you just want to find one way to actually cross that obstacle field, the output is deterministic. Things change a lot when you actually add lots of random factors on that. because it's not going to be always as easy as going through the obstacles. Actually, you've got to take into account the wind, and the wind always changes, so it will be maybe cheaper using battery to go further south if the wind is coming from the south, or further north if the wind is coming from the other direction, etc. So you take random factors on your calculus, and that becomes precisely artificial intelligence. And thanks to the greater computing power we can now have on drones, we can also take new data into account to take these decisions. So basically, I'll show you RCNN. This is a very famous image. You've all seen this kind of images with autonomous vehicles. In the automotive industry, it means just finding pedestrians, finding the other cars, finding where the walls are and where the road is, etc. We now can run these kind of algorithms on board drones directly and detect people on the ground, and for instance avoid to overfly them and take unnecessary risk. So you can not only fly by minimizing your battery consumption on board the drone, but you can also fly by minimizing the risk you've taken. And this is obviously very important for mass adoption among large companies. So I was telling you about making drones simpler and safer. That was one of the first objectives. But the fact is that actually a drone doesn't serve any purpose. It means nothing. It's just something that flies. What really matters is what you do with it, which data you get. And that's where AI something. Sorry. That's where AI also intervenes. So using not only power on board the drone, but also power on the cloud this time, you can manage your drone operations way more efficiently. That means not just having multiple drones, but dynamically assigning missions to multiple drones according to the mission criticality. I mean, if you've got a drone and you task him with just actually on a site doing a cartography, and all of a sudden there's a fire somewhere on the industrial site, you obviously want to dynamically retask the drone and give him a priority over its previous task. So the intelligence is not on board the drone, also on the cloud. You can also analyze flight data and detect an abnormality among the cloud. You can, for instance, pick the drone which has the most new battery and the less used battery to equalize the workload among a fleet. Our mission is also to provide our artificial intelligence as a platform. One of the problems large corporations actually deal with is that there's no one-size-fits-all drone. There are lots of different drones for different purposes that are more optimized for cartography, some are more optimized for flight time, etc. And that's pretty much a nightmare because you end up having a very heterogeneous fleet. You have different controllers, different way of using the drones, different buttons, different maintenance cycles, etc. And using artificial intelligence, you can actually put a lever on that and using all your different drones the very same way. Once you actually have picked the right drone for the right mission, and the platform actually tells you that you can use it because of its battery, etc., you are using AI again because you're getting into the mission. So as I said, drones are useless by themselves. They only serve a purpose, and that purpose is a mission. So what do you need them to do, actually? Our cloud platform, it allows for customers to dynamically enable different AI bricks and AI technologies for their missions. For instance, that's a conventional neural network, a CNN, that's made for counting vehicles and analyzing their trajectories. We don't do that. We don't do that algorithm. In fact, third party can use our platform to provide their own models to customers that actually use our platform. Typically, these algorithms are way too hungry to run directly on board a drone. You can have enough processing power to run them on board a drone. So we run them on the cloud, very closely to real time. Yeah, so third parties can publish algorithms. Another kind of algorithms is this time not for real-time processing, but for post-processing. So you can use AI before the flight, during the flight, and after the flight. It's a well-known problem, it's change detection. It means this time you don't take data one time, but you fly every day on an industrial site, and you compare the pictures you've taken to detect changes. This is a very old problem because it's been done by statistical filtering for literally decades, I think. But the problem is that when you use it practically on an industrial site, you get a lot of false positives. So it gets something that's in the end not used by operational people because of the false positives or false negatives. Actually, using AI, you can have humans categorize changes and find whether there are actually a change or not. I mean, so I've been telling you about a lot of use cases, and the thing is that these use cases are currently being deployed for the very first time. One of the few use cases, of course, involves security on sensitive sites. So right now we can use AI on sensitive sites to detect intrusions and qualify them, because one of the problems we've got with sensitive sites is that they are equipped with alarms, and these alarms actually ring a lot because of bad reasons, like wild animals, etc. So our solutions actually help remove the doubt whenever an alarm actually triggers. Another way of using this kind of technology is to detect critical defects on infrastructure, like electrical transformers. You can actually spot overheating cables, overheating transformers, or insulators. And AI actually helps in two ways, qualifying the defect, and also planning the mission to actually get the best chance at finding a defect. Because humans do naturally that. Humans actually look for things on the most probable place where they will find them. And most robots don't do that. They just scan the site. Yeah, so obviously it's way more optimal to have a chance at finding an abnormality. And if you intervene way
Clément,
too late,
can we just keep few? It's great, but just to keep some few time for
the last slide.
That's perfect. Thank you.
If you actually get there too late and you did not get a chance to detect the abnormality, you can still use the drones in a collaborative way and use it for crisis management. So yeah, that was the end.
Any question in the audience? Or I would start with one for you on Uavia. Maybe, so today you're selling the full solution. For example, what you showed us, which means that you're buying also the drones, you're installing the software inside the drones, and you're providing the full solution today to the customers. That's the way it's working. And is it the way it's going to work next year, in 2 years, in 3 years? How your business is going to evolve?
So thank you. That's a very interesting question. And yeah, obviously today we commercialize end-to-end solutions. And the way we are going to progressively do it is by forming partnerships with third parties. We can actually just equip industrial customers with the platform. And after that, you've got an ecosystem of partnerships and partners that can provide the hardware that directly plugs to this platform. So our ambition is not so much to actually go on the end-to-end thing, but it's more about forming an ecosystem with software partners for artificial intelligence bricks to process data, hardware partners for the machines themselves. Yeah, our key value right now is to actually put the platform among industrial customers and help them actually change the way they work and use drones.
Yes, question here. And I give you back the micro, because you're going to answer, not me.
Yeah, thanks again for a speech. We see great usage that you have and things that weren't possible before. Well, it could be used, I'm sorry to talk about it, but it can be used also the wrong way, and you could put some explosives and some other things on it. What are the different security measures that you take to avoid that these kind of things happen? Because I mean, it's important. Otherwise, I mean, the business might go down pretty quickly.
Yeah, sure. Well, that's a very interesting question, and actually, lots of people share your point of view. Pretty much every government thinks of drones as an opportunity, but also a threat. It's a reality. I'd say that my answer is going to be very generic. For every piece of technology, you've got a good side and an evil side, and that's pretty much not a lot you can do about it when you think really deeply about it. So we just work with the right people, and that's the first thing to mention. So we actually have got the luxury to actually choose among our customers, and we've got lots of requests that could actually be, let's say, dubious. And we work very closely with authorities in lots of countries to actually decide whether or not to trust the people we give that kind of technology.
I mean, yeah, you could use identification or things to stop the drone. I don't know if you have.
Yeah, you could hack the drone also, or because if you can control it, and if you're using the mobile network, I guess you can hack a drone. That's probably also your point now, I guess.
Yeah, but you could go the other way around and maybe find ways to, I don't know, have a drone if there's a risk it just falls, or I don't know what.
Yeah, so hacking is another issue. To just follow on your precise question about the wrong use, in fact, to use this kind of technology, you must have a real adoption process, and it's obviously several months long. So it's not something you're gonna just sell on the internet and everyone can buy it. So that part of the concern will be more for the DIY drones community, where you can actually do whatever you want with a drone you just buy on Amazon. It's not so much a concern for our price ranges and products. About the second part of the question about hacking, obviously two of the three co-founders were security engineers, and that's the very first thing we thought about. Because we connect drones to the cloud, so it gives them lots of power, but it also exposes them to a lot of threats. But in the end, when you add all the layers of security, and we put end-to-end encryption directly on board the drone, so the user and its computer decrypts the data that were encrypted on board the drone. Yeah, it's multi-layer security with encryption, authentication, etc. My CTO school probably provide a better answer. But in the end, what's important is that it's actually more secure to use the internet in a secure way than to just use a radio controller the way everyone does it with standard drones, if I may.
There's a question back there.
Yes. You sort of answered it in the end of your previous answer.
Okay.
But my question was about processing the data on the cloud. I was wondering whether there were some industries not willing to use the cloud because of its nature. You showed like a nuclear site. I would expect that it doesn't necessarily want to have its data on the cloud, especially from foreign companies regarding the nuclear sites. So I was wondering whether your solution was only using cloud solutions, or can you provide an infrastructure independently from the cloud providers?
Yes. So obviously, in my presentation, I oversimplify it. So we use the cloud and we use the mobile networks, but in the real world, not so much. Most of the use cases involve private IP networks, so not open networks. We actually do it on open networks every day, where flight tests are performed from our offices, and it's done on a flight test area several hundreds of kilometers farther. So we use open networks, and it's a very good way to design a safe solution and secure by design, you know. But in the end, it's get even more secure because it's often operated from private networks with private cloud too. So the data does not get to Google or Microsoft or whatever large corporation dealing with such sensitive data actually get their very own server. And our platform has been designed to be really easily set up directly inside the customer's core infrastructure and not on third-party infrastructure.
Last question.
Hi, what are your go-to-market challenges and how do you overcome them?
Well, it's a long question.
Yeah, I could probably speak about that for a few hours, which we've got at the cocktail, by the way. But I'd say the most important challenge is actually to evangelize our users, because large corporations by themselves don't have a very clear vision on where it's interesting to put drones and where it's not interesting. Also, regulatory agencies and governments, actually, we have a lot of work to perform on them and with them to actually convince them that using AI on this is actually the smart thing to do, because it's a lot more powerful than to having a human, which is obviously not flawless on the ground. So yeah, these two challenges, and in one word, it will be evangelizing our market, which is quite new to everyone, industrials, regulatory agencies, etc.
Okay, well, thanks a lot, Clément. It was very, very interesting.